Hey there, hackers! Tacit Sanctuary is back with another Advent of Code solution video of day 4. This is a word search problem, and Uiua search functions are just insane. Stay with me if you want to learn about their true power. Briefly describing the problem, we have a matrix of letters and we have to find all possible occurrences of the word Xmas in any direction, horizontal, vertical, diagonal, back and forth. That's 8 possible directions for us. We can start by copying the sample to the editor and partitioning the rows to a 2D matrix of characters. Checking the shape, the playing field looks symmetrical. Same number of rows and columns in the sample and the real data as well. We will use this to our advantage. The most basic way of searching a single element in an array is using the equals sign. That gives us a Boolean matrix of the matching positions. This can work with an array of any number of dimensions. However, we are trying to find all letters of Xmas in a group. We may call it a subarray. If we look at the first line only, we can mark all occurrences of the Xmas substring using the find function. The mask function is similar, but it covers all the elements of the subarray, not just the first one. In this case, it is not so useful because we only need to count each single occurrence of the word. We could apply the search to every row of the matrix with the rows modifier. Indeed, it works, and all beginnings of the word Xmas are marked. It appears horizontally 3 times.
But what if I told you that there is a better way?
Similar to equals, the find function is also pervasive. It will work with any depth of data. So we can find a one-dimensional substring in a 2 or more dimensional array. Once we have this knowledge, we can implement the solution with a completely different approach than in traditional programming languages. Now let's talk about directions. One approach could be to orient the search pattern or the needle in different directions.
But what if I told you that there is a better way?
We can actually rotate the search field or the haystack and use the same needle everywhere. For the diagonals, we can also apply the same logic, one needle with 4 rotated versions of the haystack. Here we can take advantage of the symmetry of the data. And at the same time, we expand the playing field from 2 dimensions to 3 dimensions, still relying on the pervasiveness of Uiua built-in functions. How to build the rotations of the letter matrix? Uiua does have a rotate function, but actually that one does something else and is not useful here. Let's observe a simple example creating a 3x3 matrix of numbers. If we reverse the rows and then transpose the matrix, we can see how it is equivalent to flipping our head sideways. To build the 4 rotations, we can repeat this step 0, 1, 2, and 3 times. We want all of these, so we can create a range of 4 and loop through them with the rows modifier so the table is turned each number of times. We have to fix the original array though, so that the full array is processed in each loop. This is going to be our rotations function. We can test it immediately with the sample data and see that the find function works beautifully here. Let's tackle the next question, how to find the text in the diagonals. We could attempt to shift each row by an increasing number of spaces so that the letters align in a straight line. Actually, this was my first attempt, before I started refactoring. There is also the option to use the stencil function, which can extract specific sized subarrays, even submatrices, and then we may compare carefully selected letters with our pattern. This function was just recently stabilized and it completely replaced the Windows function. And actually, it is really powerful.
But what if I told you that there is a better way.
We can also make our search pattern two-dimensional, and we can even use wildcards in it. So the needle could be a 4 times 4 character array with the letters Xmas placed in the diagonals, and the rest filled with wildcards. How to create this pattern? Of course, we could type in the letters, the wildcard being the \W. Or we can actually generate it. Most remarkably, during the night after this challenge was published, Kai, the creator of Uiua, already added a small capability to the language that made this easier. That's what I call real-time feature engineering. Meet the orient function, which can change the axis of a multidimensional array. Basically, it's a more powerful version of transpose. For example, in a 2D array, switching the axes 0 and 1 is the same as transposing. But we can also elevate a one-dimensional array to 2D by replicating the same axis. Only this time we need to provide a filler value, and the original elements are placed in the diagonals. And if we put the wildcard as filler, we are getting the required result. We can test this immediately with our rotated haystacks, and as expected, the pattern is actually found in each of them. The final touch is to combine both of our searches. Naturally, we can do this with a fork, because in both cases we start out with the string xmas and the rotations of the search field. Even the result arrays are the same shape, so we can easily join them, then D-shape and count all the ones with reduce plus. This is the solution for part 1. Moving on to part 2, this will be really easy now. What we have to do is make a pattern of the letters MAS placed twice in a crisscross shape. Again, we could type in the letters, or we can just get on the Orient Express again. If we check the Unicode value of the characters, it turns out the wildcard is a really large number. So making a cross shape from the diagonals, it's as easy as reversing the array and taking the minimum of both versions. It does not matter which way the letters are facing, because we search all directions anyway. And now it's really just a piece of cake to apply our find function on this pattern. We can power up our array skills by digging into the deeper dimensions of Uiua. Indeed, the pervasiveness of search functions can take our coding skill to a whole new level. Also, I want to mention again the commendable efforts of Kai Schmidt, who surprises us with more brilliant language features ever so often. If you enjoyed the video, then don't forget to show your support as usual, and feedback is welcome in the comment section. See you next time.